Now, in this video, what we're going to look at is multiple linear regression. So, previously, what I had a look at here is, let's just dig it out there, is I had a look at this cheeses data set where I had one response variable and three predictor variables. So, in that previous video, I talked about stepwise regression a bit. Okay. Now I'm actually going to present it here. Now, in this case, what I'm going to do is use a different data set, one where there is many more predictor variables, x1 to x8. So I'm going to use these. Now, what I can do here is, essentially, I'm just going to sort of try and keep this video short. So what I'm going to do here is go to Stat, Regression, Regression, and Fit Regression Model. Okay. Now I have it all set up there. That's my response variable there, y, and then the continuous predictor variables there, x1 to x8. Now, I'm going to click on stepwise here, and I'm going to click on forward selection. Now you notice I have all the potential terms there. Essentially what Minitab is going to do is pick out the best subset of those, okay, such that the model is optimal in terms of explanatory power. Okay, you don't need them all. But you need probably one or two to come up with a best predictor, a very powerful model. But sometimes you might need more. Essentially, what you do here is let Minitab try and give you what's going on. Now, down here, what I'm going to sort of do is sort of include details for each step. This is important. There's multiple steps take place. With forward selection, I'll start off with forward selection, is that we start off with no predictor variables chosen, okay? Then Minitab will pick out the best one, okay, and refit the model, and then from the rest, pick out the one that will actually improve the model, and so on. Okay, there's a good bit to it there. So include details in each step. Let's click OK. Okay. Essentially, there's a couple of things there to sort of talk about, but I'm just sort of conscious of time, and it's more reading work after this. Okay, so let's scroll the whole way up. Now we've got loads of data here. Okay, so what happened here is that in step 1, okay, seemingly x8 got picked out as the best predictor variable, okay, of the lot. And what happened then is, once x8 was picked at step 2, it decided that Minitab decided that once you had x18, which was the best of the bunch, x4 improved it, and so on. And then x3, and then x2, and then x7, and then x1. Okay? And you just actually notice down here that the r-squareds seem to get, and the adjusted r-squareds sort of go up each time. And just like, essentially what happens here is the predictive power improves the whole way through. Okay, it's very, when you have a look at this, include details of each step, you actually get a sort of good sense of what's going on. Now it just sort of folds over on itself, so it actually step 5 and step 6 are below. So it decides there that when it puts in x1 to sort of stop. Okay, the reason is probably that it's essentially once we would add in x5 and x6, that the predictive power of the model starts to decrease. Okay, so adding in x5 and x6 will sort of decrease the power of the model. That essentially the 6 we have picked there, x1, 2, 3, 4, 7, and 8, and in combination that's the best model. Whereas if we add in 5 and 6 to the model, not good. It actually starts to improve the model. Okay, now, alpha to enter 0.25. There's an analysis of variance table, which is useful in all this. Essentially, after that, we get a sort of straightforward regression output from Minitab, which is not interesting. Well, it's not different to any other sort of presentation. So all the interesting stuff here is the candidate terms, x1, x2, x3, x4, and all that. Which ones get picked, which ones don't get picked. The order that they get picked in, x8 is the best, then x4, then x3, then x2, then x7, then x1. Okay, and not 5 and 6. Let's just sort of see if this works out the same for backward regression. Okay, so stat, regression, regression, fit regression model. Okay, now go down here to stepwise, and essentially what I'm going to do here is go to backward selection, backward elimination. Okay, alpha to remove. I'm going to leave that alone. Essentially, you might sort of later down the line sort of like get a bit more a sense of what to do here. Alpha to remove and so on. But it's sort of more theoretical and I don't really have enough time to explain it. So I'm just going to leave that alone, basically. Alpha to remove and alpha to, to put in for the other case. Just going to leave that alone. Click OK. OK. Now, let's run our model again. That looks good. Nope. OK. So I think this is backward selection. Now, again, you get all the usual sort of output there. OK. And what has happened here is that the candidate, so start backward elimination of terms. So with backward elimination, you start off with all 8, okay, and then one by one you kick them out because they're not useful. Interestingly, you might notice that X1 gets kicked out straight away. Remember, that was actually selected for forward selection, but it gets kicked out straight away in backward selection, okay. Then X6 gets kicked out, X5 gets kicked out, okay, and so on. And I don't think there's many steps in this one. Yeah, no, it's actually not really. Essentially what happens here is it decides that X1, X2, X3, X4, X7, X8, that subset of the predictor variables is the optimal, okay? Now you might notice that gets a different answer from the forward selection. Backward elimination of forward selection gives us can often give us different sort of decisions on which is the best subset, okay? X2 is actually just hanging by a thread there as well. Just actually as a remark. I think like if we sort of change our settings anymore, X2 might have got kicked out. Anyway, after that, what happens is that we get the sort of usual sort of output from our linear regression equation model, okay? So it's actually just interesting the sort of the difference between forward selection and backward selection is the order that things happen in. Now one more, we'll look at stepwise regression itself. This is probably one you have to get asked. Like stepwise regression, this is probably the one you'll actually have to do for a project or something like that. But it's actually just good to know what it is. And it's a sort of mixture of both, forward selection and backward selection. So let's just click that, stepwise. Okay. Alpha to enter, alpha to remove. Let's just leave that alone. Okay. Click OK. And click OK. Now that looks good. I should remove the sort of requirement to have residual plots there. Now, stepwise selection of terms. Okay, so what happens here, okay, is that it works on a forward selection basis. Okay, first off, but what happens here is that once something has been selected, it can be deselected. So forward selection, X8, X4, X3, X2, X7, once they've been picked, they can get deselected, okay? So X8 gets picked, X4 gets picked, X3 gets picked, X2 gets picked, then X7 gets picked, okay? Let's just scroll down here. Does X1 ever get picked? Doesn't look like it. I think what happens here is that, it actually gives us the same sort of set of results as backward selection, and just what happens here is that X1 doesn't seem to get picked, or actually if it did get picked, it got kicked out. Now it probably just doesn't give that output. Now so it gives the same output as backward selection, but forward selection, X1 gets picked very early. Okay, is that forward? No, it's backward elimination. X1 gets kicked out. Sorry, I'm looking at the wrong one. Go back up here. Remember, X1 actually just manages to sort of sneak itself in. Okay. Now, this is a lot to do with the thresholds you need to sort of put in. Okay, to sort of the threshold that it must cross to be useful to be added, or the threshold that it must sort of cross to be so useful as you must, or so not useful that you must take it out. Essentially, with these alpha to remove and alpha to remain, that sort of requires a bit of reading. In a nutshell is just like forward selection, start with nothing, add in things one by one. Backward selection, start with everything and then take things out. And then stepwise selection is add a few things in, and then on an ongoing basis you might take a few things out again. That's it in a nutshell. So, okay, 10 minutes, good.